There is an island near Shanghai that most people have never heard of. A few decades ago, it was covered in farmland and orchards. Quiet, completely ordinary. Today, that same island is home to one of the most powerful industrial facilities ever built by human hands. A place where steel structures bigger than skyscrapers are assembled piece by piece, lifted by machines so large they block out the sky, and launched into the ocean as fully functioning ships the length of 4 football fields. And this is just one of dozens of facilities like it. Right now, China is building ships at a scale the world has never seen. Over 70% of every commercial ship ordered anywhere on the planet last year was built in China. The top shipbuilder in China alone produced more ships by tonnage in a single recent year than the entire United States shipbuilding industry has produced since World War II. Total, across 80 years. But the real story is not just the numbers. It is how a country went from a marginal player to the undisputed ruler of the world's most critical industry in just 30 years. And why this goes far beyond cargo and trade. If you enjoy videos about the engineering and industrial stories that actually shape the world, hit the link button, subscribe, and turn on notifications. Now let us start with something most people never stop to think about. The world floats on steel. Nearly 90% of everything you have ever bought, worn, eaten, or used came to you on a ship. The phone in your hand crossed an ocean inside a container. The fuel in your car was carried across the sea in a tanker. The wheat in your bread was loaded into the belly of a cargo ship thousands of kilometers away before it ever reached a bakery. That is not a metaphor. That is over 11 billion tons of cargo per year, carried by more than 100,000 commercial vessels that never stop sailing, crossing every ocean on the planet around the clock. Think about what that actually means for your daily life. Every single morning, before you have even had your first cup of coffee, you have already touched dozens of products that spent weeks on the open ocean before arriving near you. The clothes on your back were likely made in one country, using materials from another, shipped through a port in a third, and driven to a store in a fourth. Remove the ships from that chain and the whole system collapses. Supermarket shelves start emptying within days. Factories shut down from lack of parts and raw materials. Fuel supplies run thin. Cities that depend on imported food and energy face a logistical crisis that no government is prepared to manage. Global trade, as the world knows it today, simply cannot survive without ships. It never could. Historians have traced this dependency back centuries. But what exists now is different in kind, not just in scale. The modern global economy was specifically designed around the assumption that ships will always be there, always moving, always on time. The entire supply chain model of producing goods in one part of the world and selling them in another only works because ocean freight is reliable, enormous in capacity, and relatively cheap per unit. And yet, for all of that importance, the people and places that actually build these ships rarely get any attention at all. Most people have no idea where ships come from, how long they take to build, or what kind of industrial power it takes to produce one. That gap in public knowledge is part of why what China has done in the last 30 years is so underappreciated. Because building these ships, as you are about to find out, is one of the most demanding engineering challenges on Earth. Building something the size of a city block. The largest container ships operating today are close to 400 meters long. To picture that, stand at one end of a football field and walk the length of 4 of those fields placed end to end. That is how long one of these ships is. Its bridge sits more than 70 meters above the waterline. Its deck rises nearly 20 stories above the sea. When fully loaded, the entire vessel can exceed 200,000 tons, and it can carry more than 24,000 containers in a single voyage. If you lined up all those containers in a straight line, That line would stretch for over 140 kilometers. Now think about what it actually takes to build something like that from scratch. You need more than 50,000 tons of steel, and that steel cannot just be poured into a mold. Every plate, every beam, every structural element has to be cut, shaped, and fitted together with millimeter-level precision. Because at this scale, even a small misalignment can compromise the structural integrity of the entire vessel. You need engines so massive they take up entire floors of the ship. Not one engine, multiple engines, each capable of generating tens of thousands of horsepower, designed to push this floating mountain through Pacific storms for weeks at a stretch without breaking down. You need navigation and control systems sophisticated enough to guide 400 meters of moving steel through some of the narrowest and most congested waterways on Earth, often in poor visibility and rough weather. And then there is the assembly itself. You cannot build a ship the way you build a house, room by room, floor by floor. The tolerances are too tight, the components too heavy, and the system too interconnected. You need cranes powerful enough to lift steel blocks heavier than a fully loaded passenger aircraft. You need welders who can fuse metal under enormous pressure using techniques that hold for decades. You need engineers overseeing dozens of systems simultaneously, from propulsion to electrical to ballast, all being installed at the same time in a structure that has to function perfectly the first time it hits the water. This is not something any country can figure out quickly. It requires generations of accumulated expertise, a trained workforce numbering in the tens of thousands, industrial infrastructure that costs billions to build, and a national commitment to keep investing in all of it, even when the returns are far in the future. Very few countries have ever managed it. And the ones that did fundamentally changed the balance of power in their era. That history is worth understanding, because it is the direct foundation of where we are today. How the crown kept changing hands. 100 years ago, if you wanted the best ships in the world, you went to Britain. The shipyards of Glasgow and Liverpool were the most powerful in the industry, supplying vessels for the British Empire and for most of the rest of the world. Britain did not just lead global shipbuilding. For a long stretch of history, it essentially was global shipbuilding. The knowledge, the workers, the techniques, and the institutional memory all lived there. Other countries bought ships the same way people today buy software. They did not build it themselves. They just paid for access to it. Then World War II happened, and the old order came apart. Japan emerged from that war, with its cities flattened and its economy in ruins. But instead of waiting for slow recovery, Japanese leaders made a deliberate industrial bet. They chose shipbuilding as one of the main pillars of national reconstruction. They studied global manufacturing methods, built large and efficient shipyards along their coast, trained a new generation of workers in the craft, and focused relentlessly on cutting both costs and production time without sacrificing the quality that buyers demanded. They did not try to copy Britain. They tried to out-engineer it, and it worked. By the end of the 1970s, Japan was producing a dominant share of the world's commercial fleet. It had gone from bombed-out ruins to the undisputed leader of a global industry in less than 30 years. Then South Korea watched what Japan had done and decided to go bigger and faster. In the 1980s, the South Korean government declared shipbuilding a national strategic priority and backed that declaration with serious money and serious intent. Companies like Hyundai Heavy Industries, Samsung Heavy Industries, and Daewoo Shipbuilding and Marine Engineering rose up along the Korean coastline and constructed some of the largest shipyard complexes the world had ever seen. Enormous dry docks carved directly into the coastline, Goliath cranes with unprecedented lifting capacity, steel processing facilities that ran around the clock. But the most important thing Korea changed was not the size of the buildings. It was the method inside them. Instead of building a ship from the keel upward the way craftsmen had done for centuries, Korean yards pioneered a new approach. They broke the entire vessel into hundreds of massive prefabricated blocks. Each block was built separately, by different teams working simultaneously across the shipyard, and then the finished blocks were brought together in the dry dock and assembled like pieces of a colossal puzzle. It was faster, more organized, far more scalable, and it allowed a single yard to work on multiple ships at the same time, without the teams getting in each other's way. Within 2 decades of starting, South Korea had overtaken Japan. The entire global shipbuilding industry had to adapt to a new center of gravity. But what neither Japan nor South Korea could have fully anticipated was what came next. Because in the early 2000s, a new player entered the race. And it did not come in slowly or cautiously. It came in with a national plan, nearly unlimited capital, and a long-term determination that would take 3 decades to fully reveal itself. How China took over in 1 generation. China entered the shipbuilding industry in the early 2000s, not as an experiment, but as a strategic decision made at the highest levels of government. The Chinese leadership had studied how Japan and South Korea transformed shipbuilding into national industrial power, and they decided to apply the same logic at a scale that had never been attempted in the history of the industry. Shipbuilding was formally designated a strategic national sector. State-owned conglomerates like the China State Shipbuilding Corporation received expansion mandates and large-scale public funding. Shipyards that were once modest regional facilities were expanded into sprawling industrial complexes that rivaled entire cities in area. And brand new facilities were built from scratch, already engineered at the outset for the sizes and volumes the industry would need in the future, not just the present. What followed was one of the fastest industrial rises in modern history. In 1990, China barely appeared in global shipbuilding statistics. In 2000, it was still clearly behind both South Korea and Japan. By 2010, it had already taken the lead in total production volume. And by 2024, Chinese shipyards were receiving over 70% of all new commercial ship orders placed anywhere on the planet. In the container ship segment specifically, that share climbed above 80%. South Korea, still impressive by any historical standard, was competing for much of the remaining slice. To understand how extreme that concentration is, consider this. The top Chinese shipbuilder alone produced more ships by tonnage in a single recent year than the entire United States shipbuilding industry has produced since World War II. Not per year. Total. Across 80 years of building. The speed of that rise is genuinely hard to process. Britain spent more than 2 centuries building its maritime dominance. Japan and South Korea each invested several decades of sustained national effort to reach the top. China did it in roughly 30 years, starting from almost nothing. And it did not do it by accident or by luck, or simply because its workers were willing to accept lower wages, which is the lazy explanation that misses almost everything important. It did it through long-term industrial planning, consistent public investment, strategic decisions made at the national level, and a collective ability to mobilize human, material, and financial resources toward a defined goal at a scale very few countries in history have ever matched. To really understand what that looks like in practice, you need to go inside one of these shipyards. Specifically, the one on that island near Shanghai. Inside the shipyard that builds giants. Changsing Island today looks nothing like it did 20 years ago. Where there were once orchards and quiet villages, there is now the Jiangnan Shipyard, one of the most extraordinary industrial facilities ever built. Seen from the air, it does not look like a shipyard. It looks like an entire industrial city that appeared fully formed on the banks of the Yangtze River. Dry docks stretch for hundreds of meters along the waterfront. Steel processing buildings cover so much ground they could swallow entire city neighborhoods whole. And rising above all of it, like mechanical giants standing permanent watch, are the Goliath cranes. These machines are visible from kilometers away. Each one can lift more than 1,000 tons in a single operation and set it down with the kind of precision that a surgeon would recognize. But the real genius of this place is not how big it is. It is the method running inside it. And once you understand it, you will never picture shipbuilding the same way again. The ship is never built from the ground up. Instead, the entire vessel is divided into hundreds of separate blocks before a single crane ever moves. Some of those blocks are the size of a house. Others are considerably bigger. And every block is built simultaneously in different parts of the shipyard by entirely separate teams working in parallel. One team is assembling the engine room block. Another is building the bow section. A third is working on the midship cargo hold. A fourth is constructing the superstructure. And while each block is taking shape, it is already being fitted on the inside with pipes, electrical cables, ladders, ventilation systems, and every other internal component it will need before it ever gets moved to the main dock. When the blocks are ready, the Goliath cranes lift them one by one, hundreds of tons each, and lower them into position in the dry dock with calm, practiced precision. Teams of specialist welders fuse the joints together using techniques that take years to master and that have to hold for decades under some of the harshest physical conditions on Earth. Engineering teams inspect every seam, every alignment, and every system connection before clearing the next stage of assembly. And while all of this is happening in one dock, 2 or 3 other ships of equal size may be under construction in nearby docks at the exact same time. This parallel production system is what makes the output numbers possible. But running it at this scale requires 3 things working together without interruption. China has all 3, and no other country currently combines them in the same way. The first is steel. A single, ultra-large container ship contains more than 50,000 tons of processed steel in its structure. China produces over 1 billion tons of steel per year, more than every other country in the world combined. Shipyards never wait for their most essential raw material. It arrives when it is needed, at the right specification, at a cost that allows Chinese yards to price their ships competitively against anyone in the world. No import delays, no supply bottlenecks, no negotiating with foreign producers. The second is the supply chain. Modern ships are not just steel. They need engines, propellers, generators, pumps, navigation systems, sensors, specialized valves, thousands of meters of electrical cabling, and hundreds of other components. China has spent decades building domestic manufacturing capacity for nearly all of these items. While shipyards in other countries sometimes wait months for a critical imported part, Chinese shipyards can resolve most supply needs without ever leaving the country. The entire ecosystem is already connected, already optimized, already running. The third is the workforce. Shipbuilding demands very specific expertise. Welders who can join metal under enormous pressure with precision that holds for 30 or 40 years at sea. Naval engineers who understand how water, weight, and steel interact at extreme scale. Crane operators who move hundreds of tons through the air with calm, practiced confidence. Over decades of deliberate industrial policy and continuous education investment, China has built the largest and most experienced, skilled shipbuilding workforce in history. And because expertise compounds with every ship built, that advantage only deepens with time. These three forces, running together and backed by long-term state investment, created a system that is genuinely difficult to challenge quickly. The lead is deep. The infrastructure is already in place. But there is one more dimension to this story that most coverage completely misses, and it is arguably the most important part of all. Ships, power, and what comes next. Think about what it means to have the most advanced shipbuilding infrastructure in the world. The biggest dry docks, the most powerful cranes, the largest skilled workforce in the industry, the fastest and cheapest steel supply in history. Now ask a simple question: what else can you build with all of that? In 2022, China launched an aircraft carrier called the Fujian. It is over 316 meters long. When fully loaded, it displaces more than 80,000 tons. And it carries a technology that until very recently, only one navy in the world had ever successfully deployed at sea: electromagnetic catapults that launch fighter jets off the flight deck with a precision and power that older steam-powered systems could never match. As of 2025, the Fujian has already completed successful test launches of stealth fighters and advanced early warning aircraft using this system. That is not a future ambition. It is an operational reality. Alongside the Fujian, Chinese shipyards are also producing the Type 055 destroyer, a ship that military analysts have compared in firepower and capability to the guided missile cruisers operated by the world's most powerful navies. Equipped with advanced radar systems and dozens of vertical missile launch cells, these ships represent a category of naval hardware that only a handful of countries have ever been capable of producing. The connection between commercial and military shipbuilding here is not incidental, it is structural. The same dry dock that builds a 400-meter container ship can accommodate an aircraft carrier. The same Goliath crane that lifts cargo hold blocks lifts warship hull sections. The same welders, the same engineers, the same supply chain of steel and components. By building the world's most dominant commercial shipbuilding industry, China simultaneously built the industrial backbone of a first-rate navy. The two grew from the same roots, fed by the same investment, trained by the same workforce. That is what makes this story genuinely significant beyond trade and logistics. South Korea still leads in certain high-value categories, particularly liquefied natural gas carriers, which require cryogenic storage systems built to extremely tight engineering tolerances. Hyundai and Samsung still win contracts where technical complexity matters more than volume. Japan maintains quality-focused niches built on decades of precision. But both countries have watched their overall market share get compressed steadily over the past 2 decades, and neither is on a trajectory to reverse that trend quickly. The shipbuilding world today is effectively controlled by 3 countries, and within that group, China is not just the leader, it is operating in a category of its own. Looking forward, the next major wave is already forming. The ships crossing the oceans today run on heavy fuel oil. That is going to have to change. The global push to reduce carbon emissions means the entire fleet of more than 100,000 commercial vessels will need to be redesigned or replaced over the coming decades to run on cleaner fuels like methanol, ammonia, or hydrogen. That represents a wave of new orders potentially worth trillions of dollars. Possibly the largest fleet renewal the shipping industry has ever seen. China is already positioning itself to capture the majority of it. Contracts for gas-powered vessels are being signed with Chinese and Korean shipyards right now. Investment in alternative propulsion technology is accelerating, and automation continues to advance inside the yards themselves. with robots already assisting in welding and steel cutting at the most modern facilities. What is unfolding on the coast of China right now is something rare in the history of industry. A country decided, with full commitment and the resources to back that decision, to master the most important capability in the world's most essential transport system. And it did it in 30 years. One generation, starting from nearly nothing, not through luck or simple cost advantages, but through long-term planning, consistent investment, and a willingness to build infrastructure that would take decades to pay off. Because the planning horizon was always measured in decades, not quarters. Every ship that leaves one of these shipyards carries more than cargo. It carries a quiet, factual, undeniable statement. We built this, and the world runs on it. The cranes keep lifting. The ships keep launching. And the story of who builds the world keeps being written, one steel block at a time, in shipyards that most people will never see, but that every person on Earth already depends on. If this video changed the way you see the world, give it a like and subscribe so you never miss the next one. And here is a question worth thinking about. Do you believe any country will seriously challenge China's lead in shipbuilding within the next 20 years? Drop your answer in the comments below.